Hey everyone, and welcome to today's Explainer. We're going to be diving into this really brilliant hands-on exercise in design theory by Mr. Yee-Seng. It explores this super fascinating idea how setting up basic, rigid constraints can actually act as the ultimate catalyst for creating abstract art. We're going to see exactly how a plain old piece of paper transforms into an endless array of totally unique geometric forms.
So, how do you turn a blank piece of paper into complex abstract art? I mean, think about a completely blank canvas for a second. It's kind of intimidating, right? But how do you take something perfectly ordinary, perfectly ordered, and intentionally mess it up to create something beautiful? Well, Mr. Yee-Seng's method proves you absolutely don't need fancy, high-tech tools to pull this off. You really just need a specific sequence of actions that invite, well, just a little bit of controlled chaos into the mix.
The whole process basically boils down to three simple physical steps. First, we cut a square. That establishes our absolute order. Second, we draw some lines to introduce those chaotic intersections. And third, we just separate the shapes to reveal what we've created.
All right, let's start with step one, the perfect square canvas.
You know, every great design needs a boundary to push against, right? And here, we're seeing the precise, orderly beginning of this whole craft. We're cutting a larger piece of paper to isolate a perfect 10 by 10 centimeter square. If you look closely, you can actually see the faint pencil lines guiding the scissors there. This right here, this is our entire universe for the exercise. It represents total structure and absolute control.
Moving on to part two, introducing random lines.
Okay, so this is the exact moment where we disrupt our perfectly measured canvas. We're going to introduce two completely distinct types of geometry. We have the rigid, unyielding straight line, and then the sweeping, unpredictable curve. The real anticipation here is just waiting to see how these two opposing forces are going to interact within those super strict borders of our 10 by 10 square.
Just look at the immediate tension this creates. A single straight diagonal line slashes right through the middle, and it intersects with two different hand-drawn curves. You've got one sweeping across the bottom half, and then a tighter little circle fragment up there in the top left corner. Almost instantly, our perfect and, let's be honest, kind of boring square is fractured into this chaotic, completely new geometry just by letting these paths cross randomly.
Which brings us to step three, deconstructing the shape.
Now, I want you to actively visualize this for a second. We've got those intersecting lines permanently drawn on the paper. If you were to take a pair of scissors and cut along every single one of those pencil marks, both the straight ones and the curved ones, and then pull the fragments away from each other, what exactly are you left with? Any guesses?
Well, here's the reveal. And wow, look at how striking this is against that red background. The fragmented pieces have been pulled apart, naturally separated by those bold red borders. Now, the source text playfully lists 4 shapes for this exercise, but if you look closely at these distinct cutouts, you'll see there are actually 5 unique fragments sitting right there. Let's take a closer look at what was actually created.
Part four, analyzing the fragments. Let's break this down piece by piece.
So, here we have shape 1. It's this sweeping, almost sail-like form. And if we use that little reference diagram to trace it back to its origins, we can see it maps perfectly to the bottom left of our original square. Those perfectly flat edges are suddenly interrupted by that dramatic curve we drew, which creates a completely asymmetrical, really dynamic object.
Now check out shape 2. This one has a completely different vibe, right? It's got this distinct, super sharp geometry. Tracing it back, this blade-like shard was formed directly by the collision of our straight diagonal line and that sweeping outer curve. It almost looks like a weapon or a sharp piece of shattered glass. It's defined entirely by the clash of a straight trajectory hitting a curved one. All right, moving on to shape 3. Once again, it's a totally unique, abstract fragment, but remember, it's derived from the exact same initial rules as the others. The reference diagram shows this piece actually came from the far right edge of our original square. It's a much smaller, tighter shape. It's bounded by the original straight edge on the right, but then it's carved out by that massive curve on the left, and finally sliced right at the top by our diagonal line. So, 3 different boundaries working together to create one entirely new polygon.
Okay, now let's analyze shape 4. This is a massive, swooping, highly complex form that really dominates the space. Take a look at the reference diagram. It anchors the bottom left corner of the original canvas, but then stretches all the way up to that top left circle fragment. Now, if you recall the text from the source we mentioned earlier, this was supposedly the final piece. The text only explicitly listed up to shape 4, but, as we noticed just a minute ago,
Yep, there's our surprise.
Shape 5. This little piece was basically hiding in plain sight, tucked all the way away in the top right corner of the original square. It's bounded by the top edge, the right edge, that diagonal slice we made, and just a tiny, tiny sliver of a curve. I love this because it perfectly proves that allowing random intersections creates way more complex, unexpected beauty than you might initially plan for. The system literally generated a whole extra geometric shape totally organically.
So what does this all mean? The absolutely crucial point here is this core philosophy. Simple constraints plus random lines equals endless creative variations. This isn't just about cutting up pieces of paper. It's a fundamental lesson for literally any kind of design, whether you're drafting a giant building or just designing a small logo. By establishing strict boundaries and then introducing these unstructured random elements, you force a collision that breeds entirely new ideas. It's order and chaos working together perfectly.
Which leaves us with this final lingering thought. You've seen the methodology now. You've seen exactly how a few simple pencil marks and a pair of scissors can turn a rigid square into 5 completely unique, super dynamic pieces of abstract art. So what would happen if you changed the curves? Or what if you added a second straight line? Honestly, grab a blank square, grab some scissors, and see what you can create yourself. Thanks so much for joining me for this explainer today, and remember to keep exploring the design and the world all around you.